Okay, I think we're good. All right, so just going to quickly go over what you guys were looking at in your little investigation with this. So power functions. So in general, like we talked about, it's always going to be of the form k times x to the a. And we want to make sure that k is not equal to 0 and a is not equal to 0. Now this k and this a, they have special names that I've kind of mentioned while we've been talking. K is called the constant of variation. And A is the power. All right. So if I give you a monomial function, an equation of one, can you identify the constant of variation and what the power is? Okay. So as we were looking in that worksheet, you guys found sometimes we have to take a power function and like manipulate it a little bit so we can figure out what those numbers are, because it's not like readily available when you first look at it. So let's do a couple of these so you can kind of start to think about that. So if I had like the cube root of 8x, let's say. Okay, that is a power function. Doesn't look like one right now, but if I kind of do a little simplifying on this thing, so I make it the cube root of 8 times the cube root of x. Okay, what is the cube root of 8? 2. So I've got 2 cube root of x, but instead of writing it as the cube root of x, I can change that into a fraction, right? And what is the fractional power that goes with the cube root? 1/3. So then what I actually have here for this one is f of x equals 2x to the 1/3. Okay, so what's the constant of variation? Constant of variation is 2, and what's the power? Well, yeah, 1/3. Okay, so doing that kind of a thing. All right. Sometimes you might see some that are actually pretty easy, but might still be confusing. If I just had 2x, I mean, technically that is a power function still. So for that particular one, what's the constant of variation? 2, and what's the power? Just 1, right? Yeah. Okay. So that's one thing I want you guys to be able to do, is to do that. Also, while we're talking about identifying constants of variations and powers and all that, identify if it's actually a monomial function or not, too. Okay? So a monomial function looks the same, but there's, like we talked about, some more restrictions on the k and the a. So it is also f of x equals k times x to the a. The only difference is with this one, k is not equal to 0 and a is a whole number. And that k has a different name. When it's a monomial, we call it a coefficient. Okay? Which you've heard before. And then a is still the power. So, might ask you then, okay, identify, is the following power function a monomial function? And if so, identify the coefficient and the power then. So, of these first two, are they both monomial functions or not? Based on that definition? No? Is either one of them? Second one is. Yeah, that one works. Now, what's the problem with the first one? Why is this not a monomial function? It's got a fractional power, right? It's not a whole number for a. So we can't count that as a monomial. Now this second one, that's just fine though, because the power is 1. That's a whole number, so we're good. Okay, so that's going to be part of it. But most of what you're going to be doing is going to be focusing on the graphs. So let's just outline really quick what the different categories were that we looked at for how this graph might look, depending on how k and a might change. So again, we're looking at f of x equals k times x to the a. All right, so we had some situations. So if a was less than 0, so if we had a negative power, bless you, so if we had a negative power, what shape did that graph have? Yeah. Yeah, it looked like a reciprocal function. So in the first quadrant, it would look something like this. Okay, now if k happened to be negative, what would happen to this graph then? Right, so if k is positive, it's going to look just like that. But if k happens to be negative, it's going to flip it down. So we could have this, or could be down in the fourth quadrant like that. Okay, so what I'm going to do is I'll just have the top row of all of these are going to be what if k is greater than 0, and then the bottom row of all of them will be what if k is less than 0. Okay, the next ones we were looking at were what if this a is a fraction? What if it's something between 0 and 1? Then what one of our basic functions did it start to resemble at that point? It looks like a square root. Yep. Because really all those fractional exponents in there are different types of roots. Square root, cube root, fifth root, whatever. So it could be something like that. Or if k happened to be negative, could flip it down and make it look like that. So it could be one of those two. All right, the next kind we ran into, what if a is exactly 1? Then what does it look like? Yeah, then it's just a line. So we could have a line coming off the origin like this, or if k happened to be negative, could be coming down something like that then. But yeah, it's just going to be a line. And then finally, if a happened to be bigger than 1, what do these look like? Yeah, it looks like part of a parabola. Depending on how big the a is, it could be a really skinny one or really wide, but it's all going to have that same parabola-looking shape. And then again, if k is negative, it could do that. So what I'm going to do next is I'm going to give you an equation of a power function, and I want to see if you can sketch what it should look like in the first or fourth quadrant. Okay? So basically you're going to decide which of these 4, or which of these 8, technically, it is. Okay? Which one should it look like? Because again, this is going to be more practice. We talked about these 12 basic functions where we really should know what the shapes of them look like, so that's going to help us to work with those functions in other ways later on. And this is just another example of if you got the shape in your head and you're trying to analyze the power function, knowing what the graph looks like gets you like 90% of the way there. So that's why it's really important to kind of memorize this stuff too, of how these shapes work. So let's try it once though. So let's say we've got f of x equals negative 3 x to the 5th. And we'll do g of x equals 1/2 x to the negative 2nd. So just those two. So it'll either be the first or fourth quadrant, depending. And then see if you can sketch the correct shape for it then. All right, everybody got something for both of them? All right, so keep in mind, all I want is either the first or fourth quadrant, and that's it for each one of these. So they should look like that. So the first one, k is negative, so it's fourth quadrant. It's x to the 5th, so it's going to look like a parabola, so it's going to come down. Second one, k is positive. Doesn't matter that it's a fraction. It's positive, so that's all that matters. It's in the top first quadrant. And then the power is negative, so it's going to have that reciprocal look to it. Okay? So does that process make sense, what I'm asking you to do there? Okay. I think based on what you guys have read and what we've talked about here, kind of fleshing this out a little bit more, I think you guys are just fine getting going on your homework then. So I'll give you the rest of the time to do that. Yeah, question? It would, but because I don't have any scale on there, I can't really tell. So the only thing that I'm really concerned with is, do you have the basic shape correct? But yeah, if it's the 5th power, it probably would be pretty tight. Mm-hmm.